Hello all. Today we'll be having a webinar on DisplayPort 2.1 verification IP, a product of Truechip solutions. Agenda of today's webinar. Truechip introduction, DisplayPort verification IP overview, DisplayPort VIP block diagram, DisplayPort VIP VFM features, DisplayPort VIP monitor, DisplayPort callbacks, DisplayPort VIP scoreboard, DisplayPort VIP coverage, DisplayPort VIP test suite, and DisplayPort VIP deliverables. Truechip's introduction. Truechip is leading provider of verification IP solutions and design services. It has a P3 framework, proven solution, perfect integration, and prompt support. It has direct sales support presence across North America, Europe, and Asia. It also has R&D centers in India. It has provided VIPs for Ethernet, PCI, USB, storage, AMBA, display, and many more VIPs. Truechip's P3 framework, proven solution. VIPs always told to customers across the globe, tried and tested over multiple DLTs. Perfect integration, whether it is Caden InSiv, Synopsys VCS, or Mentor Questa simulators. Truechip VIP integration is perfect. Truechip VIP supports the universal verification methodology as well as legacy methodologies. Prompt support, known for industry's first 24x5 support, online and offline support as per the requirement. DisplayPort VIP overview. It is compliant to VESA DisplayPort 2.1 standard. DP 2.1 VIP is backward compatible with DP 2.0, DP 1.48. Can handle all speed and lane up to maximum as per specification. In addition, alt mode supported for UHBR 13.5 and UHBR 20. DP 2.1 VIP is backward compatible with DP 2.0. It is available in system verilog and UVM. OVM and VVM also supported. VIP is compatible with Mentor Graphics, QuestaSim, Cadence NC, and Synopsys VCS. Used for verification of standalone IP or in an SoC environment. It provides support for I2C over aux for EDID registers and native aux transaction for DPCD registers. Multiple LTTPR capable of supporting CTA 861G and DMT and CVT video timing standards on all colorimetry and up to 16 BPC. Capable of supporting CTA 861G audio timing standards. DisplayPort VIP key features. Supports HDCP 2.2 and HDCP 2.3 end-to-end production. 5 capable of RS FEC encoding and decoding. Scoreboard for end-to-end data integrity. Monitor compliant to DisplayPort 2.1 standard. Support all power management states. Can handle HPD plug, unplug, and interrupt request. Capable of display stream compression. DSC. Supports PIPE 5.2 and 6.0 versions. Configuration of MSA via TC sequences is supported at runtime. Reduced video frame timing is supported. Capable for bypass, link training, and EDID for faster simulation. Supports auxless ALPM signal. DisplayPort VIP architecture. It has TC test suites, compliance, basic and directed test, error injection test, random test, TC sequence library, TC environment configurations. TC source driver. It has video stream source, audio stream source, aux service channel, HPD channel, configuration channel. The DP source device is connected to the DP SST/MST mode source device via the source native interface. The DP source device has 3 different layers in it: DPTX link, DPTX MAC, DPTX 5. The DPTX link and DPTX MAC are connected via TC specific interface, and DPTX MAC and DPTX 5 are connected via the pipe interface. The DPTX link performs all isochronous transport services. The DPTX Mac performs 8-bit and 10-bit encoding, scrambling, and etc. The DPTX5 layer performs serialization. The source native interface connected from the DP source device is sent to the scoreboard. The DP SST MST source device has aux channel, HPD interrupt request, and the main link. Between the DP source device and the DP sync device, there can be a support of DP branch device, tunneling bridge, or USB Type-C. Coming to the DP sync device, which can be operated in SST mode as well as MST mode. It has also three layers: DPRX5, DPRX MAC, DPRX link. So in DPRX5, the deserializing operation is performed, and decoding or descrambling is performed in the DPRX MAC layer, and decoding of the link symbols or the video stream is done in the DPRX link. DP sync device has two outputs, which is nothing but the video output channel and the audio output channel. These channels are directly connected to the scoreboard. So in this scoreboard, both the data coming from the source native interface as well as the output received from the DP sync device are compared. We have a DP monitor which contains a transaction logger, a complete functional coverage, a protocol checker for link monitor and file monitor. Sync DUT in TCDP environment. If the DUT is a sync device, it can be plugged into the Truechip DP VIP environment. User can add both module-based or class-based DUT to the current environment, as shown in the figure below. All that has to be done is to disable the current module and instantiate the new DUT. So, in order to do that, there are three different steps which are supposed to be followed. Step number 1, adding DUT files in the VIP environment. Open TCDP user home user compile file list .f and add the path for the DUT fetch. 2. Disable the DPRX, that is VIP sync DFN. Open TCDP user home TCDP user configurations.xp file. Add the following under TCDP user override environment configuration method. TC common configuration of 1. TCDP env enable DPRX link is set to 0. TC common configuration of 1. TCDP env enable DPRX 5 is equal to 0. Note, the common configuration index will change respectively. In this case, TC environment ID for DPTX is 0, TC environment ID for DPRX is 1, TC environment ID for scoreboard is 2. Step 3. By default, scoreboard and monitors are created with the environment. To turn off any of it, open TCDP user home, TCDP user configurations.xv and add or uncomment the following under TCDP user override environment configurations method. TC common config of 1 dot TCDP env enable dpmon is equal to 0. TC common config 2 of TCDP env dp scoreboard is equal to 0. DisplayPort LTTPR VFM. In between the DP source device and the DP sync device, an LTTPR can be connected. Not only a single LTTPR, but multiple LTTPR can also be connected in non-transparent mode and transparent mode as per the specification. DisplayPort link layer BFF supports isochronous transport services over the main link, capable link and device management services over the aux channel, can handle aux transaction to access the DisplayPort configuration data DPCD address, capable of handling multi-stream packet and single-stream packet data transmission, supports 128-bit, 132-bit DP stream symbol to MTP mapping rate control mandates, supports hot plug and unplug detection and link status failure detection, capable of handling panel reply mode, supports adaptive sync operation for VESA adaptive sync, can handle payload bandwidth allocation if stream is added or removed in runtime. Support secondary data packets. Support enhanced and non-enhanced framing mode. DisplayPort link layer BFM, capable of handling video transmissions with the following options: MSA or ignore MSA video timing and or VSC. TU generation with and without FEC encoding and decoding. CTA, CVT and DMT video timing standard. RGB, YCBCR 4:4:4, 4:2:2, 4:2:0. ITU RBT 601, ITU RBT 709, ITU RBT 2020 and Adobe RGB colorimetry. Variable color depth up to 16 bpc, interlaced and progressive video is supported. Horizontal blanking expansion and reduced blanking timing as applicable. Capable of handling various types of audio on variable frequency applicable per CTA standard. LPCM audio for up to 8 channel, 1 bit audio up to 8 channel, 3D LPCM audio for up to 32 channel. DisplayPort 5-layer VFX. It supports half duplex mode of operation of aux, connected to link layer through Truechip specific system interface. Supports data with according to the pipe configuration. Maintains link training and link status monitoring. Supports Reed-Solomon RSFEC encoding and decoding as per the specification. Supports the scrambling, descrambling process as per the specification. Supports 128-bit and 132-bit and 8-bit and 10-bit encoding and decoding as per the data rate. Capable of Manchester 2 coding for aux transaction. Supports auxless ALPM signaling. Option of bypass training is also supported. DisplayPort HDCP feature. Supports HDCP 2.2 and HDCP 2.3 end-to-end protection. Can handle HDCP encryption and decryption for 8-bit and 32-bit link symbol. Capable of continuous link integrity check for all lanes and rates. Supports aux transaction for authentication protocol. Supports encryption and decryption as per Advanced Encryption Standard AES. Capable of encryption and decryption with and without RSFEC encoding and decoding. DisplayPort Monitor Overview. DisplayPort VIP Protocol Monitor is easy to plug in and is compliant to standard specifications. DP VIP Monitor performs protocol checks for both link and file, and any violation is reported as error, warning, or info depending on severity of specification. Change severity and suppress severity option is provided by the VIP monitor. Auto masking feature for error injection performed using PC callbacks. Can handle dynamic masking from sequence. Functional coverage of all configurations with configurable cover groups and cover points, which can be enabled or disabled based on the supported feature set. Provides specific error ID for all the error message with detailed description and spec section. DisplayPort error injection. Truechip DP-VIP uses listed methods which are supported by all layers and monitors to perform error injection in the test case simulation. UVM callback. Callbacks can be used from TC library with built-in functions, with option of using ready-to-use test case, or user can write their own callback from extending TC provided callback base function and packet and required test case by extending TC user test case. DisplayPort callbacks. Truechip DP verification IP is having callback mechanism to provide configurable access to the VFM without modifying the existing VFM code. DP callback class TCDP callback packet can be instantiated in the Truechip test library or user-defined test cases. Here is the list of few callback functionalities which are supported by the DP verification IP. Aux, sending incorrect packet structure, sending data length more than 16 bytes, sending illegal and invalid aux response, not responding to aux transaction in timeout method. In the main link, more pixel packed in the TU, size of TU more than 64, incorrect VBID value sent, corrupting of encoding, controlled RSFEC error injection for FSM state transitions, HPD length error injection, disable HPD IRQ behavior. These are the various callback variables and their descriptions which are currently being used in the DisplayPort VIP. For example, TC callback CR pattern error injection enable. It is used to enable error injection in the clock recovery of TPS1 sequence. And coming to number 5, TC callback TS error injection mode. It is used to set the error injection mode in training patterns such as TPS1, TPS2, TPS3 or TPS4 sequences. When value is 1, DPTX BFM error injection automatically auto error injection DP VIP test case demo. Test case name TC DP 2.1 UHBR 10 lane 4 test. Description. Read the DPCD receiver capability fields DPCD 0000H to 00003H. Read the EDIT DPCD receiver capabilities field from DPCD 00700H to 00704H. Read the EDIT DPCD receiver capabilities field for PSR capability DPCD 00070H. Write the configuration to sync device link lane count is equal to 4, link bandwidth set is equal to UHBR 10. Perform link training at set configuration. When link training is done, stop link training. Start transmit video stream 1920 x 108p at 60 Hz, 8 bpc, RGB, CTA format. Environment variables. Set env, TCDP home, absolute path where VIP is installed, TC DisplayPort _ VIP. Set env, TCDP user home, absolute path where VIP is installed, TC DisplayPort VIP, SIM, TC DisplayPort user files. Run command make -f $tccad home makefile all VIP is equal to DP, test name is equal to TC DP 2.1 UHBR 10 lane 4 test. Simulator is equal to Q for Questa, NC for cadence, and VCS for synopsis. Q count is equal to 0, TCDP version is equal to 1.
Now we are going to for the test case demo. In the test case which are running is TCDP 2.1 UHBR 10 lane 4 test. Here the UHBR 10 is the link rate and 4 is nothing but the 4 lanes as enabled. Initially we are writing 600 as 1 to power up the sync device. Later on we will be reading the capabilities of the sync device. Here we are reading the different capabilities of the sync device. Once it is done, we are setting 1 or 2 as 3, which indicates FEC configuration and making FEC ready. After that, we are writing 107 as 0, which indicates max downspread control registers. Then we are writing 108 as 2, which indicates main link channel set as 128-bit and 132-bit encoding format. Then we are writing registers 100, 101 and 102, where 100 is written as 1, which says that UHBR 10 link rate has been set. 101 is equal to 84, where lane count is set as 4 and enhanced frame mode has been enabled. 102 is set as 21, which means the TPS1 training pattern has been initiated. After that, we are waiting for the clock recovery interval to occur. Later on, we are reading the 202 and 203 registers as 11, which specifies that the CR done status has been completed on all the 4 lanes. Then we are writing 102 as 22, which indicates TPS2 training pattern has been initiated. After the channel equalization, we are reading the registers 202 and 203, which indicates that all the EQ status has been completed on all the 4 lanes. By this, we can achieve that TPS1 and TPS2 training pattern has been completed on all the 4 lanes. Once the training has been completed on all the 4 lanes, we'll be disabling the training pattern by writing 1 or 2 register as 0. After that, we are going to send ideal pattern and we are going to set the video resolution parameters here. The video resolution parameter set is colorimetry is set as legacy RGB and the data which is sent is 1920 x 108p 60 Hz, and these are the video resolution parameters set at reduced frame count. Then the sync is decoding all the video data which has been sent by the source. Once it has decoded all the data, we are going to receive a scoreboard summary report which indicates the type of transactions, aux request transactions and aux reply transactions, as well as the video data transactions and total number of transactions. Now we will be moving on to the waveform.
Now we'll be seeing the waveform for the test which you have seen in the test log. Initially, we'll be waiting for the reset to be deasserted. Once the reset has been deasserted, the source device waits for the HPD to be triggered. Once the HPD has been triggered, we'll start initiating the addresses on the aux channel. First, we are writing 600 as 1 to power up the sync device and reading the capabilities of the sync device. Here, we are reading the different capabilities of the sync device. After reading the capabilities of the sync device, we will be writing the address 120 for FEC configuration and to make FEC ready. Later on, we are writing 2 different addresses. Here, the byte count is set as 1, so 2 different addresses 107 and 108 are being written, specifying max downspread, and channel link is set as 128-bit and 132-bit encoding. Later, we are writing 3 different registers, 100, 101 and 102. 100 specifying that UHBR 10 link rate has been set, and 101 specifying lane count is 4 in enhanced mode. And then we are initiating training pattern 102. Here, TPS1 training pattern has been initiated. Once TPS1 training pattern has been initiated, we can see in the file layer that the training pattern has been initiated. We can check the CR done status on all lanes by reading the registers 202 and 203. Next, we'll be initiating the TPS2 training pattern. After initiating the TPS2 training pattern, the EQ status can be seen on 202 and 203. Now, we are going to disable the training pattern by writing address 102 as 0. Once that is done, we'll be sending the ideal pattern and the video data. So this is the test case procedure. DisplayPort VIP deliverables. DisplayPort source and sync device. DisplayPort DFM or agent for link layer 5 layer. DisplayPort layered monitor and scoreboard. HDCP, LTTPR, integration guide, user manual and release notes. Sequence library, test environment and test suites such as compliant test, basic and random test, error scenario test, coverage test, user defined test. Truechip VIP quality. Quality of VIPs. All VIPs comes with a comprehensive set of assertions. VIPs has extensive test and coverage plans. VIP has directed test to achieve 100% functional coverage. All VIPs have strong protocol checking monitors. All VIPs are tested with all industry leading simulators. VIPs are coded in system Verilog with UVM, which makes the VIP lightweight. All VIPs are being used in production by various customers. The VIPs provide a wide range of error injection scenario to stress test the DUT. Quality of engineer. Average experience level of engineers is 5+ years. Every engineer can go from specification to developing a complete VIP. Truechip ITA. Truechip has an GUI which is used for easy integration, easy debugging, easy searching, easy error detection, and easy configuration. The various advantages of the TrueEye is easy debugging, easy configuration, easy search, easy error detection, easy integration, saves time, reduced optimization, budget optimization, enhanced performance. Thank you all for listening to this webinar. You can kindly contact us using www.truechip.net or at sales@truechip.net. Thank you for joining the webinar and thank you for your time.